So for this slide, I need you to understand what a piecewise function is. It's basically uh, two or more different functions on the same graph with restrictions or intervals, and these are your restrictions. For example, they could put comma, then your restriction. They could also write for, then your restriction, or they could write when and then your restriction. It all depends on the teacher, the book that they're using, if it's going to have a comma, a for, or a when. And right here we have a piecewise function. We did this example in class. I'm just going to go over it one more time. So we have to graph our piecewise function and then evaluate the function. When we evaluate, you could evaluate straight into your equations, making sure that you know where this number lies in the restriction, or you could actually do it from the graph. But when we're graphing the graph, this right here, x plus 1, when x is less than 2 and x is greater than 2, this is basically your restriction for both of the graphs. So for the x plus 1, it only cares any numbers that are less than that 2. So all our answer has to be on the left side of that red line. For 3x minus 2, it says x is greater than 2. So that means all our possible answer has to be on the right side of that red line. So when you're graphing x plus 1, all you have to really do is, remember, your 1 is your y-intercept. So that would be 1 right there. And your rise is 1 over 1 because that's the number in front of your x. So up 1 over 1, up 1 over 1. Since it's x is less than 2, not equal, then it's an open circle. And you just extend your graph to the left side. You're going to do the same thing for 3x minus 2. But remember, you're not going to plot any points for this one until you get to the right side of 2, or the red line. So your y-intercept is 2 right here, and your rise over run is 3 over 1. So you go 1, 2, 3 over 1, no dot yet because it has not passed the red line, up 3 over 1. And again, now we hit the red line, but we know that in that red line, it's x is greater than 2, not equal. So it's open circle. And then again, we go up 3 over 1 and extend our line. And this would be our piecewise function. When we're actually trying to evaluate our function, if you look at the negative 4 it lies in this restriction, not in this one, because this right here is all the numbers that are greater than 2. These are the numbers that are less than 2. It says negative 4 is less than 2. I have to substitute it into this equation. So I would go negative 4 plus 1, and it gives me a negative 3. You could also do this on the graph, and you would go to negative 4 and find where your graph actually crosses it, and your y would be negative 3, and that would be your answer. For 1, again, the restriction lies in here, so you would go 1 plus 1, which is 2, or if you look at your graph, you look at 1, my answer for y would be 2. For this function, it would be undefined because if you notice, the two inequalities is not equal to. So it cannot be an either or. You can't substitute it in there. If you look at the graph, this is where 2 is located. And on both graphs, there's nothing there. It's an open circle and an open circle. So if there is no value when I hit 2, that means it's undefined. So for this function, we have an x squared function when x is less than 0, and a square root function, a square root of x, when x is greater than or equal to 0. Again, this is where my 0 is located. So I like to draw a little line there telling me those are my restrictions. This x squared function, which is a quadratic, a U shape, is going to focus on the left side of it. So when I graph it, I know that the parent function starts at the origin. Since its x is less than 0, I know that that part right there is not part of the solution, so I have put an open circle. And then I know for my graph, I'm going to go up 1 over 1, over 1, up 4. And the reason I got that is because I just plugged in the numbers in there. Negative 1 squared gives me 1. Negative 2 squared gives me 4. For the square root of x, I know all the answers lie on all the numbers that are greater than 0, so I know it's going to be on the right side. I know that the square root function starts at 0, and since there's an equal, I know I'm going to fill it in, so it's part of my solution. And I know for the square root, for the parent function, it always crosses to the point 1, 1, and I just extend it. You could always use a t-table and plug in numbers, see what your numbers would be for your output. Now that I have my graph, again, I could plug these values in here into the graph, depending on where the restriction lies. Since -4 is on the left side, I would have to plug it into my x squared. So if I plug it in there, I know -4 squared would be 16. 6 is x, it's an x that's greater than 0, so I would have to plug it here. And there is no perfect square limit, so that means that it's just square root of 6. I can't reduce that or simplify it. For 0, the only place where it's equal to 0 would be the square root of x. So if I have square root of 0, which is equal to 0. And again, for 2, I would have to plug it in for the square root. And since it doesn't simplify, it would be just square root of 2. For this problem, they're asking us to write a piecewise function from the graph. So if we have our graph of f of x, we're going to write a piecewise function. If you look, our restriction is going to be this line right here. And if you notice, our restriction is going to be, this is x is equal to -1. So our restriction has to be numbers that are less, where x is less than 1, and where x is going to be greater than that -1. Okay, so, and that this one of them might have an equal sign or not. So these are our restrictions, less than or greater than. If you look at your equation, this one right here, that one's going to be less because all the numbers that it's focusing on are numbers that are less than -1. So for our other function, we're going to have all the numbers that are greater than that. And if you see, it's filled in, so that means it has to be greater than or equal to x. So for our first function, this one right here is a constant. So we know it's a constant of 1. So we have 1, comma, where x is less than -1. So that's my first function. My second function is a quadratic, so I know that's going to have an x squared. The y-intercept is -3, so that'd be -3 because that's my k. And the restriction on there is all the numbers, all the x's that are greater than or equal to that -1. And that would be my piecewise function. This is our last problem that we're going to do. We're also going to write a piecewise function. So we have our f of x is equal to, we're going to have our functions, and we're going to have our restrictions. If you focus on the left side, we have this problem right here. And if you notice, it is from -3 to 0. So that means that one has a restriction. So I know it is from -3 less than or equal to x less, not equal, sorry, than 0. And let's take the equal part out. There's no equal because there is no filled in part right here. If this was filled in, then it'll be equal. Since they're both open circles, that means just less than. That would be your restriction for the left function. So I'm just going to write it right here. So we are going to have 3 less than x less than 0. And that's going to be a linear equation. Since it has a negative slope, I know that it's going to have -x. I also know that the y-intercept is going to be 2, since it's going to cross the y-axis at 2. So I'm going to have +2. I'm going to look at the slope just to confirm that it's down 1/1. So if we go here, if we go straight up and over, you notice that it went down 1/1. So it is just going to be 1/1. Now we're going to focus on the second graph right here. And this second graph, if you notice, is going to be a quadratic. Again, it has a very specific restriction. And that restriction is going to be from this point, which is 0, to that point, which is 2. So that means it's 0 is less than or equal. This one, it is equal because it's filled in right there. It's a filled in circle. and it's going to be less than 2, not equal, since there is an open circle right there. So I know now that this restriction is going to be 0 less than or equal to x less than or equal to 2. And I know it's a quadratic equation, and it starts at the origin. So, and it's, if you really look at it, it's not narrower or wider. It is just up 1 over 1. So that is just going to be a regular x squared, the parent function. And that would be our piecewise functions with the restrictions of my intervals.